All right, welcome back, everybody. 5-minute lesson. We are continuing our journey on triangles, and this is the last unit in Unit 8. Okay, in this unit, you will specifically learn about angle of depression, how to find the area of a triangle using sine. Okay, angle of depression is what we're going to look at first. So, a search and rescue team is having a nighttime practice drill. 2 members of the team are hovering at 2,000 feet. They want us to find the angles between point B, point A, and point C. Come on in, Ada.
Hey, we have some shadow meets.
Love it. We're just starting a 5-minute lesson. We're going to introduce everybody here in just a second, but since we are on a live recording right now, we're going to get to that next. So there are some, first of all, this class is full of really smart people, and there are some of those really smart people in here who have really struggled with this angle of depression. Okay? So everybody look straight out into the horizon. Okay, look straight out. You're at 0 degrees. Now, look 90 degrees down. Okay? You just formed an angle of depression with the horizon. So what you need to know is that if these guys were looking straight down, this would be 90 degrees. So A is that angle of depression. The entire thing B is that angle of depression. And then this entire thing C is that angle of depression. We'll just go in order. So let's find A first. So if I looked at this A triangle, here's my right angle. That's terrible. This is 2,000. Does everybody see where I got my 2,000 from? We're making rectangles. Since this is 2,000, then this is 2,000 as well. Does that make sense? Okay. How far away is A? It's 4,500 feet. This is the angle of depression we're looking for. According to A, what's the 2,000? Is it opposite, adjacent, or hypotenuse? It's opposite. Very good. What's the 4,500? Which one involves opposite and adjacent? So we'll say tangent of what? A. That's where our angle goes. Is 2,000 over 4,500. How do we get rid of tangent? What's the opposite function of tangent? Tangent inverse. So I have to do the tangent inverse of both sides. That cancels it. Remember, if you're trying to find an angle, what button are you going to have to hit on your calculator? The second key. You have to hit the second key. Can somebody put that in their calculator for us? Second tangent of 2,000 over 4,500. Isaac?
23.962.
Okay, now Isaac, let's just go fast because this is a 5-minute lesson. Angle B will be the tangent inverse of 2,000 over 3,200, Isaac. We're just changing this each time. 2,000 stays the same.
It's 32.05.
Okay, and then how about the tangent inverse of 2,000 divided by 1,800?
That's 48.012.
So you can see that as these pilots look closer and closer to to what's directly below them, the angle gets bigger. It's kind of how you indicate that these triangles have to be upside down in order for you to find. So all of those are angles of depression. I'm sure you have questions. I'm going to answer them individually because we got to keep going with this 5-minute lesson. So let's look at this. Oh, no. Let's look at this picture. Angle 1. Is this an angle of depression or an angle of elevation? It's an angle of depression. The horizon is at the top. Angle 2, is this an angle of elevation or an angle of depression? Elevation. The ground or the horizon is at the bottom. Angle 3, elevation or depression? compression. The horizon is at the top. Angle 4, elevation. Okay? Just a little review. Last thing I want to show you is how to find the area of a triangle using SOHCAHTOA. You don't have to memorize this if you are a problem solver. But if you're into memorizing, the general formula is the area of a triangle is 1/2 AB sine of capital C. It could also be 1/2 AC sine of what? Capital B. Or it could be 1/2 BC sine of capital A. All of these will work. They're all telling you the same thing. Why does this work? Okay, well, I don't know why they're telling you this, but they tell you F and G, and then they tell you that F is 3 and G is 4. So they give you this, okay? What's the base of that triangle as you're looking at it? What would you say the base is? 3. Thank you, Hallie. Always be brave, okay? So this is the base. What's the relationship between the base and the height? They have to form what kind of angle? So this is one of those where I would have to, the height would be there, right? Now here's what's weird. You guys don't understand this. You will maybe someday. Can you just put it in your calculator, sine of 116. Put it in your calculator. What'd you get? Somebody just give me a couple of those decimals.
8, 9, 8, 7, 9.
Thank you. 7, 9. So I'll call that an 8. Okay, thank you. Now, what's the supplement to 116? 180 minus 116, 64. Do this. What's the sine of 64? It's the same thing. That's why this works. So, if we know that according to the 64, what's the H? Is it opposite, adjacent, or hypotenuse? Opposite. And what's the 4? Hypotenuse. So that's sine. Sine of 64, which is the same thing as sine of 116, is H over 4. So what's 4? I'm sorry, what's H? It's 4 times the sine of 64, right? And what is that? 3.59 is 5. Okay, now look, what was H? It's 4 times the sine of 64. So what's the area of this? It's 1/2 4 times the sine of 64 times the base times 3. So it's 1/2 AB sine C. That's just how it works. But you don't have to memorize that if you just figure out what the height is and use 1/2 base times height to do the area, okay? The other thing that I want to bring up about what you've just done, now that you know sine, cosine, tangent, law of sines, and law of cosines, you can finally start to understand how Big Brother is tracking you. What do you all have in your pockets that might be in your book bags right now? Your cell phone. So your cell phone is attached to your person. What does your cell phone always talk to? The cell phone tower. And then what does the cell phone tower talk to? Anybody know? The satellite. The cell phone tower talks to the satellite. Well, what's going on, how GPS works, is there's a person here. There's a tower here, and there's a satellite way up here. The tower doesn't move. The satellite is moving at a constant rate, so the tower knows exactly where the satellite is. In fact, the tower is almost always the same distance from the satellite, but it can figure out the distance. And then you move around, and all that's happening is this triangle is changing. And all they need to know is 3 pieces of data, 1 angle and 2 sides, or 2 angles and 1 side. And they can figure out everything they need to. So if you ever hear about triangulating your location, this is what's going on. Okay? And so all I'm trying to get you to understand is we want to create young people that are capable of understanding things that most other young people don't understand, so that you can understand how the world works better, and that will give you a leg up. Make sense? Okay, time to work. Boom.